This instructional video is designed to show you how to compare real versus ideal gas behavior when given a particular gas and its van der Waals A and B constants. So our first step is to determine ideal pressure using the ideal gas law, and then determine the real pressure using the van der Waals equation. And so we start with PV equals nRT, and we solve for our pressure, nRT over V. So this is now a straightforward matter of plugging in our values. I'll be suppressing writing out all of the units, but they are important, just for speed of writing and clarity. So 2.50 is the number of moles. We have our gas constant, and the temperature is already given in Kelvin. And we have the volume set at 5 liters. And so under ideal conditions, the pressure that we determine is 18.46 atmospheres. Now, to compare our real pressure, we want to first write out the van der Waals equation. So we have our interaction term added in here. And the amount of excluded volume by the real gas particles here. And now we have nRT. So solving this requires a bit of straightforward algebra. So our pressure term is going to be equal to nRT divided by the volume term, V minus NV, and we will subtract off our interaction term. So now we can sub in all of our values here. So we have our number of moles, our gas constant, and our temperature. This will all be divided by the volume, which in this case is our 5 liters, minus the product of the number of moles and our van der Waals B. And as always, you should check for yourself that these units do actually work out. Now we subtract off the interaction term, 3.59. We need the number of moles, that's 2.5 squared, and the volume, 5 liters, also squared. And so we can step through all of these doing the math bit by bit. And what you should find is that you have 18.87 atmospheres. And for the interactions, we must subtract off 0.898 atmospheres. So once we complete that subtraction, we get that the real gas law pressure is 17.91 atmospheres based on the van der Waals equation. And so this shows how we can use both the ideal gas law and the van der Waals equation to determine the differences between real gas pressure and ideal gas pressure.